Okay, we're back. We're going to start again with our discussion of the graphs of the sines and the cosines. And we talked about those graphs, and we're going to start talking about the period and amplitude changes that we can perform on those. We talked about the sine graph, some properties about the sine, the periodic nature of the sine graph, which is kind of offset by this identity here. Okay, the symmetrical nature of the sine graph, which is symmetric about the origin as indicated by this property, this identity right here. Okay, talked about the domain and the range, and this other identity, which is comes about because of the symmetry of the sine. And the cosine graph, again, is periodic nature. Okay, and its domain and range, how it crosses at the quarter and 3/4 of the way through its interval, okay, and its period and its periodic nature, which gives rise to this, which will be what gives rise to all trigonometric functions in that periodic nature, and its symmetry about the y-axis, which is indicative by this identity. Now let's talk about adjusting the amplitude of the sine and cosine functions. Okay, when we put a coefficient a in front of sine and cosine, we will modify the amplitude of either of the graphs. And we recall that the amplitude was given by formulation highest value minus lowest value over 2. Okay, and that the normal sine graph is of amplitude 1. And if we now just modify that somewhat, as we'll see here, 3 sine of x, the graph would now have an amplitude of 3. And it's analogous to moving the around a circle of radius 3, if you will, now. Okay, we can move off of the unit circle and move to a circle of radius 3. But as I think I said previously, we're going to move away independent of the unit circle and just start talking about the graphs as they are, taking on a quality of their own. Okay, so 3 sine of x is as graphed here. Amplitude is now 3. It's been stretched vertically. Okay, we could stretch it or we could compress it, as is the case here. And we'll notice with this one, we've compressed it to an amplitude of 1/2, and we've also flipped it because of this negative sign here. Okay, and again, the amplitude is measured. I know you're tempted to think, oh, it's just the height of the wave, but once we start shifting these things off of the axes, you're not going to have that. So just always think highest value minus the lowest value over 2. All right. So we made a note here, changing the amplitude changes the range of the function. So the blue graph here would have a very small range, only living between -1/2 and 1/2 inclusive. Domain would be unaffected. Okay. We also note that the a value taking on a negative had the impact of flipping across the axes. Okay. The amplitude is never perceived as being negative. All right, the amplitude is always positive. So we could say the amplitude is given by the coefficient a, but really we want to just take its absolute value because we don't imply amplitude being negative because it's a measurement. And our measurements are not going to be negative. Okay, we're going to talk about now a period adjustment. Okay, so if we'll return here for a moment, amplitude was analogous to stretching this thing vertically or compressing it, as is the case in the blue graph, stretching it as we saw with the case of the green graph. Either one of those is defined as an amplitudal change. We can also bring on a period change, okay, on the function with a multiplier b here as a coefficient of the x term. Okay, so we know that our normal period for a sine graph is going to be 2 pi. There's our normal sine graph right there with a period of 2 pi. So coefficients of x are going to effectively stretch or compress this graph horizontally. Okay? So our normal graph of sine is a period of 2 pi, and is graphed there for us. We're now going to take at a alteration on the graph, and we're going to alter both the amplitude and the period just so we can have a better view of this graph. Okay, so we're going to talk about the graph 3 sine of 2x. 3 sine of 2x. So we should immediately gather that the amplitude is going to be 3. Okay, now we have a period. We have a modified period. So the modified period is given by this formulation. It's the normal period of 2 pi divided by that coefficient b. So and here's our graph here. Our period now, from our function 3 sine of 2x, our period is now 2 pi divided by 2, which gives us a period of pi. A period of pi. The period of pi means, okay, that from 0 to 3.14, we get one entire wave, okay? And the black graph also shows the stretching vertically with the amplitude. But so what we have here is in the stretch from 0 to 2 pi, we now have 2 waves. So the 2 has given us, okay, twice as many waves, but the trade-off is each wave has a span only half of its normal wave, which is determined by the formula 2 pi over b. 2 pi over b. So we get twice as many waves, but each wave is half of its normal period. Okay, so notice that the function produces twice as many waves in the normal 2 pi period. Therefore, each wave is half the normal width. We also want to share with you what we said before, okay? That the sine graph crosses the beginning, middle, and end of its cycle. Well, that has not changed when we compress this thing, okay? So the normal period is 2 pi. With now our adjustment for the black graph, our period is now pi, but we are, as we can see, crossing at the beginning, 0, pi over 2, and pi, beginning, middle, and end, even though we have compressed this. Okay, let's take a look at some variations on a cosine function here, okay? Again, same principle, 2 pi over b is the adjusted period. So we look at our normal graph of the cosine right here. Again, reiterating that the cosine crosses at a quarter and a 3/4 mark of the way. We're going to ask you to graph the new variation 2 cosine of 1/2 x. 2 cosine of 1/2 x. So the b value is 1/2, and the modified period would be 2 pi divided by that half. 2 pi divided by a half, of course, is 4 pi. So now we can see, okay, that in the stretch from negative 2 pi, this is negative 2 pi, negative 628, to positive 2 pi, we only have an entire graph, an entire wavelength, whereas previously we had 2 wavelengths. So the coefficient 1/2 in front of the x has given us, okay, half as many wavelengths, okay, half as many wavelengths, okay, but the trade-off is each wave is twice its normal stretch. Normal period, 2 pi. This is stretched it out to 2 pi. This stretched it out to 4 pi, okay? This is stretched it out to 4 pi. So in other words here, if I wanted to continue with generating this graph for an entire cycle, I'd have to, here we stop at 2 pi, and you say that's only half. Well, then if we go out to positive 4 pi, we would see an entire wave. Just like if we went in the negative direction here out to negative 4 pi, follow that through out to negative 4 pi, you would have another wave generated. Okay? So since the period is twice as long, you can expect to see half the number of waves there as you would in the normal period. Okay? So here's one we're going to ask you to construct kind of on your own. I'm going to guide you through as to how it is constructed. Okay, we're going to take a look at the graph of -2 sine of pi over 2x. -2 sine of pi over 2x. A couple things to bear in mind. Okay, we have the negative, which is flipping it. We have an amplitude adjustment, and we have a period adjustment. Okay, since a is -2, the amplitude is 2, and as we said, also the graph is flipped across the x-axis. Why is the period 4? Not 4 pi, 4, because the b value is pi over 2, and again, the period is 2 pi divided by b, so it's 2 pi divided by pi over 2. Reciprocating and changing the sign of multiplication, you can see we have a nice cancellation. So the period is 4 units. 4 units. Not your usual 6.28 units, but 4 units. So recalling what we said before, okay, that the sine graph crosses the beginning, middle, and end of its cycle. The beginning, middle, and end. Now this whole wavelength spans 4 units, so beginning, middle, and end would be at 0, 2, and 4, which would be the intercepts of the graph with the x-axis at 0, 2, and 4. So I would sketch those in. Here's the graph in its entirety. 0, 2, and 4, spanning from 0 to 4 is one whole wavelength. Midway, 2 is the midpoint. Okay, so that's what we do. We kind of indicate where we want it to cross the axes, beginning, middle, and end. And we have we're going from a range adjustment now from -2 to 2, which is you know, as indicated by the amplitude with this absolute value of -2 or 2, and we have to account for the flip across the x-axis as is the case with this negative here. Okay, we're gonna actually come back to this with another video, let you digest that a little bit, maybe look at a couple more graphs and show you how we generate the graphs again. Okay, so there you have some alterations on the graph with the amplitude and the period. The amplitude and the period, the modified period given by the formulation 2 pi over b. 2 pi divided by b will determine how the period has been modified. Okay.